They don't have eyes or ears or what we would call a nervous system, but plants can talk and they can listen. Let me show you how. First, we'll need a plant eater. This one's perfect. It's called an aphid, a hungry little critter who loves to munch on fresh green leaves. You see the aphid right there? That's aphid. Aphid. Next, we arrange lunch. We choose a bunch of young, healthy bean plants with lots of broad green leaves. See the broad green leaves? Then we carefully drop our aphid, make that many aphids, into the bean plants where they land and begin to chew. The aphids spread across the plant, biting the leafy surface, gobbling little bits of green, creating holes. And when a leafy plant is under attack, it doesn't sit quietly. Back in 1983, two scientists, Jack Schultz and Ian Baldwin, reported that young maple saplings, baby maple trees, young maple saplings getting bitten by insects release a spurt of chemicals that float through the air. You and I wouldn't notice, but these chemicals carry a slight odor that neighboring plants can detect. It's a little like a silent scream. And these chemicals come in from the injured parts of the plants and seem to be an alarm. Maybe not an intentional warning like, watch out, aphid attack, but more like a simple distress call. Aphids, 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 or attack, attack. The chemicals the plants pump through the air are a blend of organic molecules, alcohols, aldehydes, ketones, and esters. These are known as volatile organic compounds, VOCs for short. Over the last 20 years, scientists have found that all kinds of trees and plants like sagebrush, barley, corn, and yes, bean plants release VOCs when they're being invaded. It's a plant's way of crying out. But is anyone listening? Well, apparently, because we can watch the neighbors react. Do they look like they're reacting? They look a little bit concerned there, don't they? Oh, now they're really shaking. In our case, when the distress signal reaches the two bean plants on either side of our aphid-covering plant, they also emit VOCs, which are cries of their own. As you can see, they seem to be calling for help. That's my fanciful way of describing what happens next. Some plants pump out chemicals specifically designed to keep aphids away. And those smelly irritants, those are chemicals that bother you, that you don't like. These smelly irritants, especially nauseous, disgusting, or poisonous to invaders. But some bean plants do double duty. They do two things. They pump out attractants, which are perfumes designed to attract different airborne insects. In this case, wasps. Wasps are an aphid's worst nightmare. Once they arrive, the tables are turned, and the critter who was lunching now becomes lunch. Wasps. Wasps. That's a hard word to pronounce, huh? Wasps. Wasps. Well, now back to our wasps. In study after study, it appears that these chemical conversations help the neighbors. The damage is usually extensive on the first plant, but the neighbors, relatively speaking, stay pest resistant. Apparently, they heard the alarm and knew what to do. See, this guy's not having much luck. He's probably dying, and these guys are like, they're healthier because they knew what to do. Does this mean that plants talk to each other? Did the first plant in some way intentionally send its warning? Was it doing a Paul Revere? Scientists don't know. Maybe the first plant just uttered a cry of pain or was sending a message to its own branches. And so, in effect, was talking itself. A scientist called this a soliloquy. Perhaps the neighbors just happened to overhear the cry. So information was exchanged, but it wasn't a true intentional back and forth. Still, the more they look, the more scientists discover plants chattering. It's pretty spectacular what plants do, Ted Farber of the University of Lausanne told Quanta magazine. I'm amazed. Not only do plants use airborne chemicals that they send signals underground through the roots, some make ultrasonic clicking sounds. What feels to us like a clicking sounds. What feels to us like a quiet day in the forest may in fact be a hurly-burly, a very busy hurly-burly or a big busy situation, hurly-burly of wafting, pulsing, clicking, plant-to-plant communication. All right, where are we now? Plant communication. Okay, communication. There we are. Now, what's the antelope have to do with the sagebrush and tobacco plant? Well, let's find out. Sometimes the chatter leaps across the species lines. Scientists have simulated an animal attack on sagebrush. In the American West, pronghorn antelopes regularly grab onto sage. They bite, they grab, they take. They grab onto sage with their teeth and tear off leaves when it's time for lunch. In the lab version, this is when they're testing it in the lab version, in the laboratory. In the lab version, the animal's teeth ripped the sage leaves. Scientists watched the sage plant send a chemical signal, into the air, and watched as a nearby tobacco plant picked up the signal and then emitted an odor that was noxious to the animal, strong enough to repel the antelope, protecting itself, and arguably helping the sage. What a complex dance. Charles Darwin, 150 years ago, imagined a world far busier, noisier, and more intimate than the world we can see and hear. Our senses are weak. The world is buzzing. Darwin sensed this. Let it be borne in mind how indefinitely close-fitting are the mutual relationships or relations of all organic beings to each other. Now let me repeat that again. Okay. Let it be borne in mind how infinitely close-fitting are the mutual relations of all organic beings to each other. I like that expression, infinitely close-fitting. It suggests there's a whole lot going on that we're just hearing our first peep.